Hello guys, welcome to the brand new chapter of organic chemistry where we're going to learn hydroxyl compound. So let's have a look at the content of hydroxyl compound. So we're going to learn about nomenclature of alcohol, physical properties of alcohol, chemical properties of alcohol, phenol and its properties, and industrial applications and its effects to human. So through the passive question, alcohol is actually quite an important chapter. Yeah. Okay, now alcohols has a hydroxyl group of OH bonded to a saturated carbon, so that alcohol carbon atoms may be part of a simple alkyl group as in some of the following example, or may be part of a more complex molecule such as cholesterol. Alcohol are classified as primary, secondary and tertiary alcohol depending on the number of carbons surrounded to the alcohol. So therefore, if the alcohol is surrounded by no carbon or one carbon, so we call it as a primary alcohol. If the alcohol is surrounded by 2 carbons, then we call it as a secondary alcohol. And if the carbon is surrounded by 3 carbons, then we call it as a tertiary alcohol. So compound group that have a hydroxyl group attached to the directly to the benzene ring is called as a phenol. So this is a phenol, yeah? Okay, so now how to name alcohol. So here are the steps of how to name them. Find the parent chain of the molecule, one with the greatest number of carbon with OH in it, and name the parent chain according to the number of alcohols, so therefore alkane XO lah. Okay, number 2, identify the substituent in the parent chain. So the substituent is an alkyl or halogen, so below show some examples. So if there is more than one type, so the name arranged according to the alphabetical order. And if there are 2 or more similar substituents, the prefix is placed, 2 for di, 3 for tri, 4 for tetra, and so on. And finally, place the number of the substituent based on the number that you placed in the step 1 earlier lah. Okay, so I'm going to set 2 examples for you. So if you have this one, so step 1 is look for the longest parent chain with OH in it. So it seems that this is the longest. So since you have a 6 carbon and the OH is located at carbon number 1, therefore hexane 1O. So you have this this is a methyl, this is an ethyl, and this is an ethyl. Okay, so ethyl first, then methyl. So something ethyl, something methyl. Now since you have two ethyl, so we're going to put a prefix di in here, so diethyl. And finally, based on the numbering, so this is carbon 1, this is carbon number 2, 3, 4. So therefore we have 3, 4 diethyl, 4 methyl, hexane 1O. So if you have a condensed formula, so open up the condensed formula. So this will be the parent chain. So when the parent chain has a total of 7C. So 7C, and the OH is located at the 3rd C in here. Okay, and then next step is you're going to identify the parent chain inside there. So you have this is a ethyl, this is a ethyl, this is a methyl again. So you have ethyl and methyl. So ethyl first, then methyl. And if you have 2 ethyl, so you have diethyl. And finally, since the number has been decided since in the first step, so this is C1, C2, C3, C4, and C5. So therefore you have 5,5 diethyl, 2 methyl, heptane 3O. So this is how you are going to name some of the alcohols. Okay, so finishing about the nomenclature, so we are going to have a look at isomerism of alcohol. Alcohol, similar to haloalkane, easily exhibit different structural or constitutional isomerism, since the position of the OH forms different isomer of alcohol. So below show some examples of the isomer with the formula C4H9O and C5H11OH. So if for C4H9OH, we have butan 1O, butan 2O, 2-methyl propan 1O and 2-methyl propan 2O. So in terms of classification, this is a primary alcohol, this is a secondary alcohol, this is also a primary alcohol, and this is a tertiary alcohol. If for C5 you contain 8 isomers, so we have pentane 1O, pentane 2O, pentane 3O. Then you have 2-methyl butan 1O, 3-methyl butan 1O, 3-methyl butan 2O, 2-methyl butan 2O, and also 2,2-dimethyl propan 1O. So these are all the possible isomers in C5H11OH. So a few of them will exhibit optical isomerism. So let's together learn how to identify them. So for a 4C, so for alcohol with 4C can easily exhibit the optical isomerism in butan 2O. So this is the chiral carbon atoms. So it is surrounded by 4 different groups: CH2, CH3, CH, OH, and also H. Okay, as for C5, you have a 3 optical active isomer, pentan 2O, and then you have this one, 3 methyl, and last but not least, this one. So these are the 3 isomers with the optically active alcohol. Okay, so if you want to express optical pair, then you can express optical pair accordingly. So finishing about the isomerisms, straight away we go to the physical properties. So as going down to homologous series, similarly, boiling point increase when going down to homologous series. However, alcohol exhibited, alcohol is to say exhibited a higher boiling point compared to other functioning group that we discussed so far, because it can form hydrogen bond between the molecule. However, the hydrogen bond strength are weaker when going down to the homologous series due to the decrease in the polarity of the molecule. So weak van der Waals forces become more significant and therefore increase the boiling point of the alcohol when going down to homologous series. So what is the effect of a straight chain and branch chain? As usual, we said that a straight chain alcohol will have the highest boiling point, followed by a branch chain, and the more the branch, the lower the boiling point. And then in terms of the number of the OH, you have butan 1O with 117 degrees Celsius, butane 1,2-diol with 2 OH, you have 208, and butane 1,2,3-triol, you have 274. So with the increase of the number of the hydroxyl group inside the alcohol, the strength of the hydrogen bond increase, therefore increase the boiling point. So compared to alkane and haloalkane, alcohol has a higher boiling point. So in here, ethanol has the highest boiling point because it is formed by the strong hydrogen bond between molecules. So fluoroethane is slightly higher because fluoroethane is slightly polar molecule compared to propane. So the weak van der Waals forces are stronger than propane because propane is considered as a non-polar molecule. Then it goes to have a look at the solubility of alcohol. So generally, hydrogen bond occur of alcohol give 2 important properties. First is it causes the boiling points of alcohol to be higher, and it causes lower alcohol groups such as methanol, ethanol to be completely miscible in water due to the formation of the hydrogen bond between the alcohol and also water. However, the solubility decreases with the increase of the number of carbon. This is due to the non-polar properties of the alkyl which attached to the carbons increases, so the hydrogen bond will become less and less significant, therefore will become less and less soluble in water. So ethanol is a good solvent for both polar and non-polar because it contains a non-polar alkyl group, and you also have an OH in it. So this is the one that caused the ethanol to be soluble in water, and this is the one that caused the organic solvent to be soluble, to cause the organic compound to be soluble inside ethanol in here. Then in terms of acidity of alcohol, so as mentioned earlier in the chapter 1, you can review back on our earlier lesson. So alcohol is generally a very weak acid, because when alcohol deprotonated, an alkoxide is formed as a conjugate base. So according to the equation, so you can see that it is a conjugate base. So the negative charge of oxygen atom is more stable compared to nitrogen. However, it's still less stable compared to a halogen. So alcohol are more acidic than amines and alkane, but less acidic than hydrogen halide. So pK of mostly alkyl alcohol falls between the range 15 to 18. So this is what we have mentioned just now. So usually to deprotonate alcohol, we use a very electropositive metal such as sodium or potassium. According to the equation, when you have alkyl alcohol react with sodium, you form the salt plus hydrogen gas. So a few factors that can explain the stability of alcohol and phenols are described below. So this is the pKa given to you in cyclohexanol, pKa 16, and also phenol, pKa 10. So from here, we can see that phenol is a stronger acid compared to cyclohexanol. So why is phenol more acidic compared to cyclohexanol? Because when phenol deprotonated, it forms a stable phenoxide ion. So this phenoxide ion is stabilized by the resonance structure shown to you in here below. So as a result, equilibrium shift more to the right, hence increase the acidity. However, cyclohexane oxide does not form the resonance, hence are less stable. Furthermore, the OH bond inside the cyclohexanol is bonded strongly, therefore equilibrium favor to the left. There is also an alternative way which you can use to explain this. The alternative way, which is an easier way, is we are going to describe as cyclohexane is an electron donating group. So when electron donating group, it donates the electron density to the O, making the OH bond become stronger, so equilibrium shift to the left. Whereas the benzene in here act as an electron withdrawing group. So when it acts as an electron withdrawing group, so it causes the O minus here to be more stable. So equilibrium shift more to the right. So that is why phenol is a stronger acid compared to cyclohexanol. Now this strength of acidity can be compared when you dissolve in sodium hydroxide. So when phenol react with sodium hydroxide, you form a sodium phenoxide and water. So this is basically a neutralization reaction, while alkyl alcohol cannot do this because alkyl alcohol are not it's not a stronger acid to react with sodium hydroxide. So this is often the test used to distinguish the acidity between alkyl alcohol and also phenol. Other factors that can affect the stability include, number 2, inductive effect. So if you are to compare between these few alcohol, for example, let's say if we were to compare between propan 1O and ethanol, okay, so note that propan 1O is a weaker acid compared to ethanol. Why? Because an alkyl chain in the propan 1O is longer, therefore the electron donating effect is increased. As a result, OH bond becomes stronger and harder to deprotonate and decrease the acidity. As for when you compare in between ethanol, 2-chloroethane and trichloroethanol, you can see that acidity increase as the number of chlorine increase. This is due to the electron withdrawing effect caused by the presence of the chlorine inside the molecule, which result the alkoxide ion form to be more stable. As electron density of the O- decrease, so greater the number of chlorine, greater the electron withdrawing effect, equilibrium shift more to the right, therefore a stronger acid it is. So these are the few factors which so far I can discuss with you about acidity of alcohol, and I believe that is all for right now, my clips for today. So see you in the next lessons.